Hi everyone, so welcome back to the November 2023 AHL paper 1. So today we're doing question number 5. So this is maximum mark 6 and it says the binomial expansion is given. Okay, so what I want you guys to think about first whenever binomial expansion is given is these formulas right here. I pulled them up on the formula booklet which is given in the exam, so you should use this wisely. It's subtopic 1.9 SL. So it's the main formula we have to use is this one. A plus B raised to n is equal to a n plus n c1, a n minus 1, b plus dot 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 plus dot n c r a n minus r b raised to r plus dot 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 plus b to the n. That's our main formula, guys. Okay, so now what I want you guys to think about is how do we implement this in our question. This is written like this: 1 plus kx raised to n, right? This is a and this is b. So a is equal to 1, b is equal to kx. So now we just have to replace them here. That's it. As simple as that. And by the way, you have to go in order. So, uh, okay, I'll tell you when I'm doing it right now. So first thing is obviously 1. And 1 raised to anything is what? 1, right? 1 raised to 0, 1 raised to 1, 1 raised to 2, 1 raised to 3 is always going to be 1. First time is 1, hence plus nc1, so that is nc1, and we have kx because uh, n minus 1, and we have the nc1 a raised to n minus 1. So then after this, we have our next term, which will be k raised to 2 and x raised to 2. And so basically it goes like a pattern. So we have NC1, NC2, NC3, NC4. It keeps on going like that. That's why there's given NCR A n minus RB raised to R, right? So that's our general formula given. So we can use this to, gain an understanding of how to solve this question. So what I will write now is the next term. So the next term will simply be plus nc2, obviously. So our R value is going to be 1 in the first case, right? And 1 over here. Now our value is 2. So in the formula, we have to change something, right? So in the formula now, we have to use this. We have to say 1, and then obviously anything raised to 1 is 1. So it doesn't really matter, but b raised to r is the one which is changing, right? So b raised to r, now we have kx raised to 2, like that. Okay, so that's the only thing that changes over here, because anything raised to 1 is 1, so no need to worry. And what we are given in the question is only 12x, and we're given 28k squared x squared, which is essentially what we've written. I can expand this. This one is essentially nc2 k square x square, right? Because when I apply distributive property, both will get multiplied out and it becomes like this, right? So if I rewrite this so you guys understand a little bit more better, I'll just rewrite this as 1 plus nc1 kx plus nc2 k square x square plus dot dot dot. And obviously we can have our generic formula like this. Minus 1 like this. Essentially it's like this, and anything raised to 1 is 1, so yeah, it's essentially we can leave it at that for the formula because we don't need to spend anything more on the formula. But now what we need to do in a binomial is we need to always compare. Okay, so the comparing part comes to this portion right here. Okay, so what we're given in the question is this whole thing right here, right? So what we first want to do is what is 12x going to match with? So if we remove the x, and always NC1 will always equal whatever is, you know, the n. So for example, if I write this out using the NCR formula that's given here, so NCR formula is right here, right? So you can just copy this like this, and first I'll just copy this so I can show you where everything goes. So in our case, 1 is r, right? Become n factorial upon 1 factorial into n minus 1 factorial. Now what is this eventually going to be? N. Okay, so if I show, let's say an example is like, I'll take an easy example, 3C1. We'll solve this just to show how it'll equal whatever is the n. Okay, so essentially now what I'm just testing is the formula and how it works to show you guys and so you guys can understand. So 3C1 in this case would be in our formula 3 factorial uh, upon the 1 factorial, and then n minus of r, just like this. And in our case, n is 3. So we have now 3 factorial upon 1 factorial is 1. So we just have now 2 factorial because 3 minus 1 is 2. So what is this? 3 times 2 times 1 upon 2 times 1. What's this? 6 upon 2, which is 3. Just proved it, right? So hence this is proved that NC1 will always equal whatever the n value is. So hence in the generic case, it NC1 is equal to n, right? So I'll erase this now. I'll keep this so you guys can understand. So, okay, so we have said it's equal to n, right? NC1. So now we know that it's equal to that, essentially, right? So nkx is equal to 12x. That's what we have, right? Because of this. This is essentially 1 plus nkx plus nc2k square x square, right? So nkx equals to 12x. What is this? X cancel both sides, nk equals to 12. I mean, this will not be that useful, but we can write this to get a mark, essentially. Okay, so I want you guys to write this on the exam to get a mark. You have to write as much as you can. You have to get those method marks. There are a lot of method marks in maths, so make sure you get those method marks. So then next what we will do is use the nc2k squared kx squared. Now this is where we'll actually start to solve, I believe. Let's see if that happens. Okay, so nc2. So now if I come to nc2k squared x squared. So we'll now, first I want to solve what is nc2, right? You can write this as n factorial upon 2 factorial into n minus 2 factorial. Now, don't we already know that nc2 k squared x squared is equal to 28 k squared x squared? I know. So all we have to do is now just we can disregard this, essentially cancelled. So we have n factorial 2 factorial into n minus 2 factorial is equal to 28. Right? Isn't this a beautiful question, guys? So, how do we how do we simplify this now? So, now let me teach you guys some more. So, n factorial upon n minus 2 factorial is essentially what we've got now, because 2 factorial is like this, where we have um, 2 into 1, so we have 2. So we can just bring out the 2 over here, and we can put it like this. Let me get this organized, 1 second. This is equal to 28 as we wrote. Now, 2 into 1 is equal to 2 factorial, right? So we have 2 n minus 2 factorial is equal to 28, and we have n factorial upon n minus 2 factorial is equal to 56, right? Let's multiply 2 on both sides, so that's how you can get rid of the 2 from here. So I just wanted to write that out in steps so you guys can understand it better. So now what we want to do is simplify this, right? So n factorial upon n minus 2 factorial. So this will be equal to, obviously, I want you guys to memorize this, okay? So n factorial. What is it essentially? It's just like 5 factorial will be, I'm going to take an example. 5 factorial will be what? 5 times 4 times 3 times 2 times 1. So what would a generalized form be for n factorial? N factorial is essentially n into n minus 1 into n minus 2 factorial, right? That's it. As simple as that. Because we're just coming down, essentially this is 5, 4, 3, then keeps on going, right? It's repeating. So I like teaching with the numbers because then students and people tend to understand, so it should help. So n into n minus 1 into n minus 2 factorial upon n minus 2 factorial. So what do we see now? What's common? N minus 2 factorial. So cancel these two. And we are left with n into n minus 1, and that will be equal to 56, right? So then now we have n squared minus n is equal to 56, right? So now we can solve this. So n squared minus n minus 56 is equal to 0. This is simple using algebra, obviously. What you guys recognize here? Easy. N minus 8 into n plus 7. Verify this once. N squared plus 7n minus 8n minus 56. Yeah, both are equal. So we can use this. So n plus 7 is ruled out because that's a negative. N plus 7 equals to 0. So that's n equals minus 7. Right? Minus 7. This is not possible. Not possible. Since it's negative. So only possible answer is n minus 8 is equal to 0. This n is equal to 8. Okay? So we have n is equal to 8. And now we want to solve for k as well, right? And this is very easy since we've did nk is equal to 12. Now this is where it comes in handy. So now we can substitute. So 8k is equal to 12. K is equal to 12 upon 8. Simplify this. You can divide it by 4. We have 3 upon 2 is equal to k. So that's our answer. It's as simple as that. So I hope you guys understood. And yeah, if you guys have any questions, please do comment and I will respond. So yeah, thanks for watching. Please do share this video and subscribe and do like the video. Thank you guys. Bye.